Welcome to Beyond the Stars, where tonight we journey to Mars, the red planet that has captivated human imagination for thousands of years, a world of rusty deserts, towering volcanoes, ancient riverbeds, vast polar ice caps, mysterious methane plumes, and countless mysteries waiting to be discovered by future generations of explorers, both robotic and human. This peaceful exploration will guide you through 100 fascinating facts about Earth's neighboring planet as you drift gently toward restful sleep, allowing the wonders of the Martian landscape to wash over you like a quiet dust storm settling across endless dunes under a pink butterscotch sky, painting everything in shades of rust and ochre while you relax into contemplation. Tonight is not about sensational claims or dramatic revelations designed to shock or excite, but rather a calm and thorough contemplation of the fourth planet from the Sun, the world most likely to host future human colonies within the next few decades. And perhaps the place where ancient microbial life once thrived, billions of years ago, when Mars was a warmer, wetter world with a thick atmosphere capable of sustaining liquid water on its surface for extended periods. Let your breathing slow, your body relax completely, and your mind wander peacefully across Martian plains as we explore this fascinating world together. Discovering the science, history, and ongoing exploration of humanity's next great destination beyond Earth and our moon. The first fact about Mars is that it orbits the Sun at an average distance of approximately 228 million kilometers, roughly 1.5 times Earth's distance from our star, placing it just beyond our planet in the Sun's family of worlds, in what astronomers call the outer edge of the habitable zone, where conditions might possibly allow liquid water to exist on a planet's surface under the right atmospheric conditions. The second fact reveals that Mars is named after the Roman god of war, chosen by ancient observers, because the planet's distinctive reddish color reminded them of blood and violence. Though we now know this rust-colored appearance comes from iron oxide, essentially rust, covering much of the Martian surface in a fine dust that gives the entire planet its characteristic hue when viewed from Earth or from approaching spacecraft. And this color is so distinctive that Mars has been called the Red Planet for thousands of years. The third fact tells us that Mars is the second smallest planet in our solar system after Mercury, with a diameter of approximately 6,792 kilometers measured at the equator, which is roughly half the diameter of Earth and only about twice the diameter of our moon, making it a relatively small world compared to gas giants like Jupiter and Saturn. And if you could place Mars next to our planet like celestial billiard balls, it would look like a smaller sibling, compact but still substantial, with enough mass and gravity to retain a thin atmosphere and maintain geological activity throughout much of its history. The fourth fact is that despite being considerably smaller than Earth, Mars boasts some of the most dramatic and extreme geological features in the entire solar system, including Olympus Mons, which is the largest known volcano anywhere, Valles Marineris, which is the largest canyon system, and enormous impact basins like Hellas Planitia that dwarf anything found on our world, demonstrating that planetary size does not necessarily correlate with geological drama or interest. And if this gentle exploration of the Red Planet helps you unwind at the end of your day, if these Martian mysteries provide the perfect backdrop for peaceful sleep and relaxation, if you find value in this contemplative approach to astronomy and planetary science, we warmly invite you to subscribe to Beyond the Stars and enable notifications so you can join us each week as we explore cosmic wonders with this same thoughtful and peaceful methodology that prioritizes understanding over sensationalism. The fifth fact reveals that Mars has only about 38% of Earth's surface gravity due to its smaller mass and size, meaning if you weigh 100 pounds on Earth, you would weigh only 38 pounds on the Martian surface. And this reduced gravity would allow you to jump nearly 3 times higher than on Earth lift objects that would be impossibly heavy back home and move with a bouncing gait that astronauts describe as feeling somewhat like walking on the moon, but with slightly more. The 12th fact brings us to Mars's atmosphere, which is incredibly thin and tenuous compared to the substantial blanket of gases that surrounds Earth, with a surface pressure averaging only about 600 pascals, or approximately 0.6% of the atmospheric pressure at sea level on our planet. Roughly equivalent to the pressure you would experience about 35 kilometers above Earth's surface in the middle stratosphere, where only specialized research aircraft and high-altitude balloons can operate. The 13th fact reveals that this extremely thin atmosphere is composed primarily of carbon dioxide, which makes up about 95% of the total by volume, with smaller amounts of nitrogen at about 2.8%, argon at about 2%, and trace amounts of oxygen, carbon monoxide, water vapor, and other gases, creating an atmospheric composition radically different from Earth's nitrogen-oxygen atmosphere. The 14th fact tells us that the lack of substantial oxygen in the Martian atmosphere means that humans cannot breathe it, and the extremely low pressure would cause exposed bodily fluids to boil at normal body temperature, even if oxygen were present. So astronauts exploring Mars will require fully pressurized spacesuits similar to those used for spacewalks in orbit. The 15th fact is that Mars has extremely cold temperatures that would be fatal to unprotected humans, with an average global surface temperature of approximately -63 degrees Celsius. Though this average conceals tremendous variations, ranging from about -140 degrees Celsius at the winter poles in the depths of the polar night to a relatively balmy 20 degrees Celsius near the equator on a summer afternoon when the sun is high in the sky. The 16th fact reveals that these extreme daily and seasonal temperature variations occur partly because the thin atmosphere cannot effectively transport or retain heat, acting like a very poor insulating blanket. So while direct sunlight can warm the surface during the day, this heat rapidly radiates away into space after sunset, causing temperatures to plummet by 100 degrees Celsius or more overnight in some locations. The 17th fact tells us that Mars experiences enormous dust storms that can grow to engulf the entire planet in a globe-spanning tempest that obscures the surface from orbital observation and blocks most sunlight from reaching the ground. And these planetary-scale dust storms occur roughly once every 3 to 4 Martian years, typically when Mars is near perihelion, and increased solar heating creates powerful atmospheric circulation patterns. The 18th fact is that Martian dust is extraordinarily fine, with particle sizes typically smaller than cigarette smoke, averaging only about 3 micrometers in diameter. And this superfine dust contains iron oxide minerals that give it the characteristic rust-red color. And when suspended in the atmosphere, it creates the pink to butterscotch-colored sky that has become one of Mars's most iconic visual features. The 19th fact reveals that despite the sometimes dramatic appearance of Martian dust storms, the winds driving them are actually relatively weak in terms of force applied to objects, because the thin atmosphere means there is very little mass being moved. So even a wind blowing at 100 kilometers per hour on Mars would exert roughly the same force as a 10 kilometer per hour breeze on Earth. The 20th fact tells us that Mars has clouds despite its thin atmosphere, The 28th fact brings us to the dramatic surface features that make Mars one of the most geologically fascinating worlds in the solar system. For despite being smaller than Earth, this rust-colored planet boasts geological structures that dwarf anything found on our home world. From volcanoes reaching heights 3 times Mount Everest to canyon systems that could span the width of the United States. The 29th fact reveals that Mars is divided into two dramatically different hemispheres with distinct elevations and characteristics known as the crustal dichotomy, with the northern hemisphere consisting mostly of smooth volcanic plains called lowlands that lie several kilometers below the planetary average elevation, while the southern hemisphere is dominated by heavily cratered ancient highlands that tower several kilometers above the mean. The 30th fact tells us that scientists continue to debate the cause of this dramatic north-south dichotomy, with leading hypotheses including a gigantic impact by a Pluto-sized object in Mars's early history that excavated the northern hemisphere, ancient plate tectonics that were later locked in place when Mars' interior cooled, or large-scale mantle convection patterns that pushed material to the south while the north subsided. The 31st fact is that Mars is home to Olympus Mons, a name meaning Mount Olympus, after the legendary home of the Greek gods, and this is the largest known volcano in the entire solar system. A shield volcano built by countless lava flows over hundreds of millions of years that towers approximately 22 kilometers above the surrounding plains, nearly 3 times the height of Mount Everest, measured from sea level, with a base covering an area roughly the size of the state of Arizona, or about the same as the entire British Isles. The 32nd fact reveals that Olympus Mons is so massive and its slopes so gradual, averaging only about 5 degrees, that if you stood on its summit looking toward the horizon, the base would be beyond your visible horizon in every direction, and you would have no sense of standing atop a mountain, but rather would perceive yourself as being on a very gradual slope extending infinitely into the distance. And the volcano's caldera complex at the summit contains 6 overlapping collapse craters spanning 85 kilometers across. The 33rd fact tells us that Olympus Mons sits in a region called the Tharsis Plateau, a vast, elevated volcanic province that hosts not only Olympus Mons, but also 3 other enormous shield volcanoes called Arsia Mons, Phobos Mons and Ascraeus Mons, and this concentration of volcanic activity has created a massive bulge in Mars' crust that actually affects the planet's center of mass and rotation. The 34th fact is that these Martian volcanoes grew to such enormous sizes because Mars lacks plate tectonics, so instead of a volcanic hotspot creating a chain of progressively older volcanoes, as a tectonic plate moves over it like Hawaii on Earth. A Martian hotspot can remain stationary beneath the same point on the surface for hundreds of millions of years, allowing lava to pile up into truly gigantic structures limited only by the mechanical strength of the underlying crust. The 35th fact reveals that Mars also hosts Valles Marineris, meaning Mariner Valleys, after the Mariner 9 spacecraft that discovered it in 1971, and this is the largest canyon system in the entire solar system. The 41st fact brings us to one of the most profound questions about Mars. Where did the water go? For the Martian surface is covered with features that unmistakably indicate the presence of flowing liquid water in the ancient past, including vast networks of dried riverbeds, ancient lake basins, and delta formations where rivers once emptied into standing bodies of water, demonstrating that Mars was once a very different world from the cold, dry desert we observe today. The 42nd fact reveals that some of these valley networks appear remarkably similar to river systems on Earth, with branching tributaries carved by flowing water, indicating that billions of years ago, Mars had a warmer climate, with a thicker atmosphere capable of sustaining liquid water on the surface for extended periods, and these ancient waterways can be traced for hundreds of kilometers across the Martian landscape. The 43rd fact tells us that scientists have identified what appear to be ancient shorelines, suggesting that an enormous ocean may have once covered much of Mars' northern lowlands, containing more water than the Arctic Ocean on Earth. Though this hypothesis remains controversial, and continues to be debated among planetary scientists who examine the evidence for and against such a massive body of water. The 44th fact is that Mars still contains substantial amounts of water today, but nearly all of it is frozen either in the polar ice caps or locked beneath the surface as permafrost. And radar observations from orbiting spacecraft have detected vast underground ice deposits extending from the poles to the mid-latitudes in both hemispheres, representing a significant reservoir of frozen water that future human colonists might be able to access and use for drinking water, oxygen production, and rocket fuel. The 45th fact reveals that in 2018, scientists announced the discovery of what appears to be a large underground lake of liquid water beneath Mars' southern polar ice cap, detected through radar reflections that suggest a body of extremely salty water that remains liquid, despite temperatures well below the normal freezing point. Though subsequent studies have questioned whether these radar signals truly indicate liquid water or might represent something else entirely like clay minerals. The 46th fact tells us that recurring slope-linear dark streaks that appear on Martian slopes during warm seasons and fade during cold seasons were initially thought to be caused by flowing briny water seeping from underground sources, generating tremendous excitement about potential present-day liquid water on Mars, though more recent analysis suggests they might be formed by flowing sand or atmospheric processes rather than water, demonstrating how Martian science continues to evolve with new observations and reinterpretations. The 47th fact is that Mars loses water to space constantly through a process where ultraviolet light from the sun breaks apart water molecules in the upper atmosphere, and the lightweight hydrogen atoms can then escape Mars' gravity and drift away into space, while the heavier oxygen atoms remain behind to oxidize surface materials. And over billions of years, this process has contributed significantly to the planet's transformation into a desert world with only trace amounts of atmospheric water vapor. The 48th fact reveals that some craters on Mars show evidence of past hydrothermal systems, where underground water was heated by volcanic activity, creating conditions that on Earth support thriving microbial communities around hot springs. The 55th fact brings us to humanity's exploration of Mars, for no other planet beyond Earth has been studied so intensively, with dozens of spacecraft having visited the red planet since the space age began in the 1950s and 1960s. And more missions are planned for the coming decades, as Mars remains our primary target for robotic and eventually human exploration of the solar system beyond our own planet and its moon. The 56th fact reveals that the first successful Mars mission was NASA's Mariner 4, which flew past the planet in July 1965 and returned 22 grainy black and white images showing a cratered, moon-like surface that initially disappointed scientists and the public, who had been hoping to see evidence of canals and vegetation that early telescopic observations and science fiction stories had suggested might exist on the red planet. The 57th fact tells us that the Viking 1 and Viking 2 missions, which landed on Mars in July and September 1976 respectively, were the first spacecraft to successfully operate on the Martian surface for extended periods, conducting experiments that searched for signs of present-day life, but returned ambiguous results that scientists are still debating nearly 50 years later, with some researchers suggesting that the Viking biology experiments might actually have detected organic compounds that were subsequently destroyed by harsh oxidizing chemicals in the Martian soil. The 58th fact is that Mars Pathfinder, which landed on July 4, 1997, carrying the small Sojourner rover, demonstrated that mobile robots could explore Mars and navigate around obstacles, and it captured the public imagination with its images of a rusty desert landscape strewn with rocks under a pink sky. showing that Mars was a real place with weather, geology, and a beauty of its own, rather than merely an abstract concept in astronomy textbooks. The 59th fact reveals that the twin rovers, Spirit and Opportunity, which landed on opposite sides of Mars in January 2004 for missions originally planned to last just 90 Martian days, far exceeded all expectations, with Spirit operating for over 6 years until it became stuck in soft sand and could no longer generate enough power to survive the Martian winter, and Opportunity functioning for nearly 15 years, traveling over 45 kilometers before a global dust storm in 2018 finally ended its remarkable mission. And if you're still with us on this peaceful journey through Martian discoveries, if these facts about the red planet help you drift toward restful sleep while expanding your knowledge of our planetary neighbor, we would be honored to have you subscribe to Beyond the Stars so you can continue exploring cosmic mysteries with us each week. And by subscribing, you support the creation of thoughtful astronomical content that prioritizes depth and contemplation over sensationalism. The 60th fact tells us that Opportunity traveled over 45 kilometers across the Martian surface during its mission, far exceeding any distance traveled by a vehicle on another planet, and it made numerous important discoveries, including definitive evidence that liquid water once flowed across Mars's surface, finding hematite spherules nicknamed blueberries that form in the presence of water, and examining layered rocks that appear to be ancient sediments deposited in standing water, all of which help paint a picture of ancient Mars as a potentially habitable world. The 61st fact is that the Curiosity rover, a car-sized, nuclear-powered mobile laboratory, landed in Gale Crater in August 2012 and represents a dramatic increase in capability compared to earlier rovers, carrying 10 sophisticated science instruments totaling 75 kilograms to analyze Martian rocks, search for organic molecules, measure radiation levels, and assess past habitability in unprecedented detail. The 62nd fact reveals that Curiosity discovered ancient lakebed deposits containing clay minerals and organic compounds in Gale Crater, demonstrating that this region once held a long-lived lake with conditions potentially suitable for microbial life billions of years ago, with freshwater key chemical elements and energy sources that could have supported organisms if they evolved on Mars, making Gale Crater one of the most intensively studied locations for understanding Mars' ancient habitability. The 63rd fact tells us that the Perseverance rover, which landed in Jezero Crater in February 2021, is searching for signs of ancient microbial life by examining rocks that formed in what appears to have been an ancient river delta, where water-carrying sediments from the surrounding highlands emptied into a lake, and Perseverance is collecting samples that will eventually be returned to Earth by future missions, representing the first step in an ambitious multi-mission campaign to bring Martian rocks back to terrestrial laboratories where they can be analyzed with instruments too large and complex to send to Mars. The 64th fact is that Perseverance carries a small helicopter called Ingenuity that became the first aircraft to achieve powered controlled flight on another planet when it lifted off from the Martian surface in April 2021. Demonstrating that aerial exploration of Mars is possible despite the thin atmosphere that provides very little lift, and opening possibilities for future flying scouts that could survey terrain and guide rovers to interesting locations more efficiently than orbital reconnaissance alone. The 65th fact reveals that Ingenuity was designed as a technology demonstration, expected to make only 5 flights, but it exceeded all expectations and completed dozens of flights over many months, sometimes scouting routes for Perseverance and other times flying to areas the rover couldn't reach, proving that aerial platforms could become valuable tools for Mars exploration and potentially leading to more sophisticated helicopters or even fixed-wing aircraft in future missions. The 66th fact tells us that multiple nations have successfully sent spacecraft to Mars, including the United States, Soviet Union, European Space Agency, India, China, and United Arab Emirates, demonstrating that Mars exploration has become a truly international endeavor that brings humanity together in pursuit of scientific knowledge and the expansion of our presence beyond Earth. And the success of these diverse missions shows that multiple approaches and perspectives contribute to our growing understanding of the Red Planet. The 67th fact is that China's Tianwen-1 mission, which arrived at Mars in February 2021, successfully deployed the Zhurong rover that explored Utopia Planitia in the northern lowlands, making China the second nation after the United States to operate a rover on Mars and contributing valuable data about Martian geology, mineralogy, and climate from a region that had not been explored at ground level before. The 68th fact reveals that future Mars missions being planned include sample return efforts to bring Perseverance's collected rocks back to Earth aerial platforms, more capable than Ingenuity deep drilling missions to search for subsurface water and possibly present-day life, and eventually human expeditions that will write new chapters in the story of Mars exploration and potentially establish permanent human presence on another world for the first time in history. The 69th fact brings us to perhaps the most profound question about Mars. Did life ever exist there? And the search for an answer to this question drives much of Mars exploration. For evidence of past or present Martian life would revolutionize our understanding of biology and demonstrate that life is not unique to Earth, potentially indicating that living organisms might be common throughout the universe wherever suitable conditions exist. The 70th fact reveals that Mars appears to have had conditions suitable for life during its early history over 3 billion years ago, when the planet was warmer and wetter with a thicker atmosphere, liquid water on the surface, and possibly a protective magnetic field similar to Earth's, creating an environment that might have allowed primitive microbial life to emerge from non-living chemistry through processes similar to those that led to life's origin on Earth. The 71st fact tells us that the building blocks of life, including organic molecules, which are carbon-based compounds, have been detected on Mars by the Curiosity and Perseverance rovers. Though these organic compounds could have formed through either biological or non-biological chemical processes, such as meteorite delivery or abiotic synthesis, and distinguishing between these possibilities requires careful analysis of the molecular structures, isotopic compositions, and geological contexts in which the organics are found. The 72nd fact is that in September 2025, NASA announced that Perseverance had discovered a rock with chemical signatures and structures that could potentially represent evidence of ancient microbial life, including what appear to be organic molecules associated with patterns that resemble fossilized microbial mats on Earth. Though scientists emphasize that non-biological processes could also explain these features, and definitive proof will require returning the samples to Earth for detailed laboratory analysis. The 73rd fact reveals that this potential biosignature discovery, found in a rock nicknamed Chayava Falls, includes leopard spot-like patterns containing organic compounds alongside minerals that on Earth typically require water to form, creating an intriguing combination that warrants further study, though it falls short of definitive proof of ancient Martian life. And this discovery highlights both the promise and the challenges of searching for ancient life on another planet, where we must rely on indirect evidence and cannot conduct the full range of tests available in terrestrial laboratories. The 74th fact tells us that even if Mars harbored life billions of years ago, during its warmer, wetter period, conditions on the modern Martian surface are extremely hostile to life as we know it. With intense ultraviolet radiation due to the lack of an ozone layer, oxidizing chemicals in the soil that break down organic molecules, extremely low temperatures, averaging -63 Celsius, and the near vacuum of the thin atmosphere, creating multiple simultaneous challenges for any potential organisms, making it unlikely that life survives on the present-day surface, though subsurface habitats might be more hospitable. The 75th fact is that some scientists speculate that if Martian life exists today, it would most likely be found deep underground, where liquid water might persist in aquifers or hydrothermal systems protected from surface radiation and temperature extremes by kilometers of rock. In environments analogous to the deep subsurface biosphere that exists several kilometers beneath Earth is surface, where microorganisms thrive in total darkness, extracting energy from chemical reactions involving rocks, water, and dissolved gases. The 76th fact reveals that certain terrestrial microorganisms called extremophiles can survive and even thrive in conditions similar to some Martian environments, including high salt concentrations that depress the freezing point of water, extreme cold approaching -40 Celsius, intense radiation levels and desiccation. The 81st fact brings us deeper into Mars's geological composition and internal structure, for the red planet's rocks tell a story spanning billions of years from its violent formation through periods of volcanic activity and water flow to the cold, dry desert world we observe today, preserving in layers and minerals a record of environmental change that planetary scientists work to decipher. The 82nd fact reveals that Mars formed approximately 4.5 billion years ago from the same cloud of gas and dust that created the Sun and other planets. And during its first few 100 million years, it was bombarded by countless asteroids and comets that delivered water and organic molecules, while also generating enough heat to melt much of the planet's interior, allowing it to differentiate into distinct layers. The 83rd fact tells us that Mars differentiated into layers early in its history, with heavier iron and nickel sinking to form a core roughly half the planet's radius, while lighter silicate minerals rose to form a mantle and eventually a solid crust, creating a layered structure similar to Earth, though with important differences in composition, size, and thermal evolution that have profoundly affected the two planets' geological histories. The 84th fact is that Mars' core appears to be partially liquid based on how seismic waves travel through the planet. Information gathered by the InSight lander, which operated a seismometer on Mars from 2018 to 2022, detecting hundreds of Marsquakes and providing the first detailed look at the Martian interior, revealing that the core is larger and less dense than previously expected, possibly containing lighter elements like sulfur mixed with iron. The 85th fact reveals that Mars once had a global magnetic field generated by a dynamo in its liquid core, similar to Earth's magnetic field, but this field shut down approximately 4 billion years ago for reasons still not fully understood, possibly related to cooling of the core or a massive impact that disrupted the dynamo process, and this loss had catastrophic consequences for the planet's atmosphere and climate. The 86th fact tells us that the loss of Mars' magnetic field had catastrophic consequences for the planet's atmosphere because without magnetic protection, the solar wind could directly strip away atmospheric particles, and over billions of years this process removed most of Mars' original thick atmosphere, transforming it from a potentially habitable world with liquid water into the cold desert we see today, demonstrating the critical importance of magnetic fields for maintaining planetary habitability. The 87th fact is that Martian rocks analyzed by rovers show diverse composition, including basaltic volcanic rocks, Similar to those found on Earth is ocean floors, sedimentary rocks formed in ancient lakes and rivers containing clay minerals and other alteration products, and impact breccias created when meteorites shattered and mixed together different types of rock, providing a geological library that records different periods in Mars history. The 88th fact reveals that some Martian meteorites found on Earth contain tiny bubbles of trapped gas, whose composition matches the Martian atmosphere measured by Viking landers, providing definitive proof of their origin and allowing scientists to study actual pieces of Mars in terrestrial laboratories without having to bring samples back from the planet. And these meteorites range in age from about 150 million to over 4 billion years old. The 89th fact tells us that volcanic activity shaped Mars during much of its development, with minerals typical of basaltic volcanism identified in many places. And basalts form when relatively pristine material from the planet's mantle is partially melted to form magma, which rises in large bubbles and emerges at the surface as lava, creating the smooth plains and enormous shield volcanoes that dominate parts of the Martian landscape. The 90th fact is that fretted terrain on Mars contains a complicated mix of cliffs, mesas, buttes, and steep-walled canyons, typically 1 to 2 kilometers high, where the land seems to transition from narrow, straight valleys to isolated mesas. And many of these features are surrounded by lobate debris aprons that were once thought to resemble rock glaciers. But radar studies with the Mars Reconnaissance Orbiter showed they contain pure water ice covered with a thin layer of rocks that insulates the ice. The 91st fact reveals that lineated valley fill found on the floors of steep-walled valleys shows ridges and grooves that in high-resolution images resemble alpine glaciers on Earth. And it is now generally agreed that glacial flow of ice caused these lineations as ice moved through canyons and valleys, demonstrating that Mars has experienced multiple climate periods, including ice ages when glaciers extended far from the polar regions. The 92nd fact tells us that inverted relief appears in some areas of Mars, where features that were once depressions like streams are now elevated above the surrounding terrain, occurring when valleys were filled with material like lava or cemented sediments that became more resistant to erosion than the surrounding landscape. And as wind eroded the softer material away, the former valley floors remained as raised ridges recording the paths of ancient waterways. The 93rd fact is that Yardang's long boat-shaped ridges carved by wind-blown sand found in desert areas on Earth appear extensively on Mars, in regions like the Medusae Fossae Formation, where they are thought to result from weathering of huge ash deposits from volcanoes. And Mars has the biggest known volcanoes in the solar system, which probably ejected much fine-grained material that was easily eroded to create vast fields of Yardangs. The 94th fact reveals that sand dunes are common on Mars, with an enormous erg called the circumpolar dune field surrounding most of the North Polar Cap. And these dunes are covered by seasonal carbon dioxide frost that forms in early autumn and remains until late spring. And high-resolution images show that Martian dunes are subject to modification via grain flow, triggered by seasonal carbon dioxide sublimation, a process not seen on Earth. The 95th fact tells us that chaos terrain on Mars consists of areas of jumbled, broken terrain, where the surface appears to have collapsed, possibly when underground ice melted or underground water was suddenly released. And many of the enormous outflow channels that carved valleys across the Martian lowlands appear to originate from chaos terrain regions, suggesting catastrophic release of subsurface water or ice. The 96th fact is that pedestal craters on Mars are impact craters that sit on raised platforms, or pedestals above the surrounding terrain, formed when material ejected during the impact protected the underlying surface from erosion while the surrounding landscape was worn away by wind, leaving the crater perched on a pedestal like a geological monument to ancient impacts. The 97th fact brings us to Mars' two small moons, Phobos and Deimos, which are among the most intriguing objects in the solar system due to their small size, irregular shapes, and mysterious origin. And future missions to these moons could provide valuable information about Mars's early history, while also serving as staging points for human exploration of the red planet. The 98th fact reveals that Phobos orbits at an altitude of only about 6,000 kilometers above Mars' surface, making it the closest moon to its planet in the entire solar system. And this proximity means it experiences strong tidal forces from Mars that are causing it to spiral slowly inward at about 1.8 centimeters per year, meaning that in approximately 50 million years, Phobos will either crash into Mars or be torn apart by tidal forces to form a temporary ring system around the planet. The 99th fact tells us that Phobos completes 3 orbits around Mars every Martian day. And because it orbits faster than Mars rotates, it rises in the west and sets in the east, as seen from the Martian surface, unlike most moons, which rise in the east. And from Mars' equatorial regions, Phobos would appear to race across the sky, completing its journey from horizon to horizon in just over 4 hours. The 100th fact is that Deimos, the smaller and more distant of Mars's 2 moons, orbits at about 23,000 kilometers altitude and takes about 30 hours to complete 1 orbit, moving slowly enough across the Martian sky that it would remain above the horizon for more than 2.5 Martian days before setting. And from the Martian surface, both moons would appear quite small, with Phobos subtending about 1/3 the angular diameter of Earth's moon and Deimos appearing star-like. Now, as we complete our journey through 100 facts about Mars, let us reflect on what this remarkable planet means for humanity's future in space and our ongoing quest to understand our place in the universe. Mars represents not merely another astronomical object for scientific study, but rather humanity's next great frontier beyond Earth and our moon, where we may establish permanent settlements within the coming decades, creating a backup location for human civilization and expanding our species beyond a single world for the first time in history. The challenges of sending humans to Mars are enormous, including the 6 to 9 month journey through deep space, where astronauts will be exposed to cosmic radiation and microgravity. The need to carry or produce all necessary supplies, including oxygen, water, and food. The psychological effects of isolation and confinement in a small spacecraft far from Earth, and the difficulty of returning safely after completing the mission on the Martian surface. Despite these challenges, multiple space agencies and private companies are developing plans and technologies for human Mars missions, with realistic timelines suggesting that the first crewed landing could occur in the 2030s or 2040s. And these missions will represent one of the greatest achievements in human history, comparable to the Apollo moon landings, but far more ambitious in scope and duration. Establishing permanent human presence on Mars will require solving numerous technical problems, including producing oxygen from the carbon dioxide atmosphere through processes like electrolysis, extracting water from subsurface ice deposits or atmospheric humidity, growing food in Martian greenhouses using soil enhanced with nutrients, generating power through solar panels or possibly nuclear reactors, and constructing radiation-shielded habitats, either by building underground or covering surface structures with meters of Martian regolith. The red planet offers valuable resources that could support long-term human settlement, including water ice that can be converted to drinking water, oxygen and rocket fuel, carbon dioxide atmosphere that can provide carbon for manufacturing and oxygen through chemical processing, iron-rich soil that could be processed to produce metal for construction, and potentially useful minerals and ores that future colonists might mine and refine. Some visionaries like SpaceX founder Elon Musk have proposed extraordinarily ambitious plans to establish a self-sustaining city on Mars, with eventually 1 million inhabitants, though most experts consider this goal extremely challenging, requiring technological breakthroughs we haven't achieved. Massive resources and infrastructure, and solutions to problems we haven't fully identified yet. But the dream of making humanity a multiplanetary species continues to inspire Mars exploration efforts. The scientific value of human Mars missions extends far beyond what robotic explorers can achieve, because human field geologists can make observations and decisions in real time that would take rovers days or weeks to accomplish. Humans can access difficult terrain that robots cannot safely navigate, and astronauts can perform complex sample collection and on-site analysis that automated systems cannot match, potentially answering fundamental questions about Mars' history and whether life ever existed there. International cooperation will likely be essential for successful human Mars missions, because the technical challenges and costs are so enormous that pooling resources and expertise from multiple nations makes practical sense. And joint missions would spread the financial burden while creating diplomatic benefits and ensuring that Mars exploration represents all of humanity rather than a single nation. Mars also offers important lessons about planetary science and climate that inform our understanding of Earth, because by comparing two rocky planets that started similarly but evolved so differently, we gain insights into planetary processes, climate systems, and the conditions necessary for long-term habitability. And understanding how Mars lost its magnetic field, thick atmosphere and surface water helps us appreciate the delicate balance that keeps Earth livable. The planet continues to surprise scientists with new discoveries, from recurring slope lineae that might indicate present-day water activity to methane plumes, whose source remains debated, to potential biosignatures in ancient rocks, demonstrating that despite decades of intensive study, Mars still holds many secrets waiting to be uncovered by future missions and eventually by human explorers walking across its rusty surface. As robotic exploration continues, with increasingly sophisticated rovers, orbiters, and eventually sample return missions, we move steadily toward the day when humans will follow in their tracks. And the first person to set foot on Mars, making footprints in the red dust under a butterscotch sky, will mark a pivotal moment in human history, when we became a truly spacefaring civilization, no longer confined to our birth world, but reaching outward to explore and potentially settle other planets in our solar system and beyond. And as we conclude this peaceful exploration of 100 fascinating facts about Mars, the red planet that has captivated human imagination for thousands of years, if you've stayed with us through this entire contemplative journey, learning about Martian geology, atmosphere, water history, and future exploration, we would be deeply grateful if you would subscribe to Beyond the Stars, enable notifications so you never miss our weekly cosmic explorations, share this video with others who appreciate peaceful astronomical content, and leave a comment telling us what aspect of Mars fascinates you most. For your support helps us continue creating this thoughtful educational content that prioritizes depth understanding and contemplation over sensationalism. Mars has held a special place in human culture since ancient times, when civilizations, including the Babylonians, Egyptians, Greeks, Chinese, and Maya, all carefully observed the red planet and recorded its movements across the night sky, with the Babylonians tracking Mars as early as 1500 BCE and incorporating it into their astronomical predictions and astrological interpretations that influenced later cultures. The planet's distinctive reddish color, caused by iron oxide on its surface, led many ancient peoples to associate Mars with warfire and blood. And the Romans named it after their god of war, creating an association that persists in popular culture today, where Mars often appears in science fiction as a place of conflict, adventure, and danger. In the late 19th century, astronomer Percival Lowell became convinced that he could see artificial canals on Mars through his telescope at Flagstaff Observatory, and he interpreted these as irrigation systems built by an advanced Martian civilization struggling to bring water from the polar ice caps to arid equatorial regions as their planet dried out. And Lowell's passionate advocacy for intelligent life on Mars captured public imagination and inspired countless science fiction stories, despite the canals being optical illusions. The idea of Martians became deeply embedded in popular culture through works like H.G. Wells' War of the Worlds, published in 1898, which imagined hostile Martians invading Earth in tripod machines. Orson Welles' 1938 radio adaptation that reportedly caused panic among listeners who thought it was real news, and countless subsequent books, films, and television shows featuring Mars as the setting for adventures, encounters with aliens, and speculation about life beyond Earth. When better telescopes and eventually spacecraft revealed Mars's true nature as a barren, cold desert without canals or cities, many people felt disappointed that the planet wasn't as exciting as they had imagined, but the real Mars turned out to be far more interesting than the fictional versions, with its towering volcanoes, vast canyons, evidence of ancient water, and the ongoing scientific quest to determine whether microbial life ever existed there. Mars continues to inspire not just science fiction, but also serious scientific and philosophical discussion about humanity's future in space, about whether we should attempt to terraform Mars, transforming it into an Earth-like world with thick atmosphere, liquid water, and eventually ecosystems, and about the ethics of potentially contaminating Mars with Earth organisms or altering a pristine planetary environment before we fully understand it. The concept of terraforming Mars, which would take centuries or millennia if it's even possible, involves releasing greenhouse gases to warm the planet, perhaps by vaporizing the polar ice caps with orbital mirrors or nuclear explosions, thickening the atmosphere until liquid water can exist on the surface, introducing hardy microorganisms to begin building soil and eventually creating conditions where plants and possibly animals could survive, creating a second home for Earth life. Such ambitious planetary engineering raises profound questions about humanity's right to alter other worlds, about preserving Mars in its natural state for scientific study versus transforming it for human benefit, and about the responsibility we would bear for any consequences of such massive environmental modification, questions that become more urgent as human Mars missions draw closer to reality. Mars reminds us of Earth's fragility and the importance of protecting our home planet's environment, because Mars appears to have lost its thick atmosphere and surface water through processes we're still working to understand, transforming from a potentially habitable world to a frozen desert. And studying this planetary transformation helps us appreciate how special Earth's conditions are and how easily they might be disrupted. The Red Planet also teaches us about perseverance and the long-term nature of scientific exploration, because understanding Mars has required decades of patient observation, multiple missions including many failures, gradual accumulation of data from orbiters, landers, and rovers, and the collaborative efforts of thousands of scientists, engineers, and technicians working together toward common goals that transcend national boundaries. Every opposition of Mars, when Earth passes between Mars and the Sun, bringing the planets relatively close together, provides optimal viewing conditions for observers with telescopes. And these oppositions occur roughly every 26 months, offering patient amateur astronomers opportunities to see Mars as a bright reddish star, showing subtle surface features and polar ice caps through good telescopes under steady atmospheric conditions. As space agencies and private companies continue developing technologies for Mars exploration, including more capable rovers, sample return missions that will bring Martian rocks to Earth for detailed laboratory analysis, and eventually human expeditions, we stand on the threshold of a new era in planetary science and human spaceflight that will write new chapters in the story of Mars and humanity's expansion into the cosmos. The question of whether life ever existed on Mars or might still exist in subsurface refuges remains one of the most profound scientific mysteries of our time. And definitively answering it requires bringing carefully selected samples back to Earth, where instruments far more sophisticated than can be sent to Mars can search for biosignatures, molecular fossils, and other evidence that would indicate biological activity. And we invite you to subscribe and follow our channel so you can learn about these discoveries as they happen in coming years. Mars orbits the Sun, with Earth, Venus, and Mercury in the relatively narrow habitable zone, where conditions might allow liquid water to exist on a planet's surface, and the fact that at least one planet in this zone developed abundant life, while another nearby world apparently did not, despite having water in its past, raises profound questions about how common or rare life might be in the universe and what specific conditions are necessary for its emergence and long-term survival. As you drift toward peaceful sleep tonight, carrying with you these 100 facts about Mars, remember that this red world continues its eternal orbit around our Sun, a planet of rust-colored deserts, towering volcanoes, ancient mysteries, and future promise. Where rovers we sent continue their patient work analyzing rocks, searching for signs of past life, and preparing the way for human explorers who will someday follow in their tracks. The mysteries of Mars invite us to look beyond our own world, to ask questions about our cosmic neighborhood and our place within it, to dream of future possibilities while working patiently to understand present realities, and to recognize that the same curiosity that drove ancient peoples to watch Mars move across their night skies continues today.